Alright, hello geometry. Today we are looking at congruent triangles. But before we get to triangles, we're looking at congruent shapes in general. So in order for two shapes to be congruent, their corresponding sides need to be congruent and their corresponding angles need to be congruent. So it needs to be both of those things. So if we got something like this, where we have corresponding sides that are congruent, but our angles are off, that's not congruent. Or if we have something like this, where our angles are congruent, but our sides are different, those aren't congruent either. So in order to be congruent, our sides and our angles both have to be congruent. So it's got to be both. So something like this, where these angles are congruent, and these angles are congruent, and all of our sides are congruent. So all the sides, all the angles. Now, eventually we'll get into some things with triangles where if we know some of the sides, then we automatically know the others. If we know some of the angles, we automatically know the others. But for right now, all the sides and all the angles have to be congruent in order for our triangles or polygons in general to be congruent. And the first thing we're doing with these is we're going to be writing some congruence statements. So congruent statements are just a shorthand way of saying this polygon is congruent to this polygon without going through and writing out every single part. Now, we could go through and write out that our side AB is congruent to our side FD. And our side BC is congruent to our side DE. And our side AC is congruent to our side FE. And same sort of thing with our angles. So we can say that angle A is congruent to angle F, and angle B is congruent to angle D, and angle C is congruent to angle E. But if we want to talk about the polygon as a whole without having to go through and list off all our corresponding parts, then we can also say this. We can say that triangle ABC is congruent to triangle, and then when we're naming this one, we want to make sure we go in the same order as we named the last one. So if we're calling this one triangle ABC, then we want to start over here at the angle that goes with A. So the angle that goes with A is angle F. So we're going to call this triangle FDE. Now, we don't have to go in exactly that order as long as we go in the same order on both shapes. So instead of calling this ABC, I'd call this triangle CAB. So we call that triangle CAB. That's fine as long as over here we go in the same order starting with the same angle. So the one that goes with angle C will be angle E. So we call this triangle E, and then the one that goes with A, the one that's corresponding to A is going to be angle F, and then the one corresponding to angle B is going to be angle D. So which order we're going in doesn't matter as long as we're going in the same order on both of your triangles, which is pretty easy as long as the triangles are, in the same position. So if they're facing the same way, it's usually pretty easy to tell, well, this one goes with that, that one goes with that, and that goes with that. Boom, 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 boom. We're in the same order. It gets a little bit trickier if our triangles are flipped. And I forgot to put letters on these ones. We'll call this triangle TRI, and then ANG for triangle. So if we want to write a congruent statement for this one, we can, again, start in any order over here. So I'm going to call this triangle TRI. And then we're just looking for which angle over here goes with angle T, because that's what we started with over here. So if we started with T, we're looking for which angle over here goes with that. And angle T is my right angle over here. So I'm looking for my right angle over here, which is angle A. And then if we went to angle R next, then we're looking for the one that has two of those lines there that's making congruent to angle R over here. So the one that goes with that over here, the corresponding angle is angle G. And then process of elimination, the one that's left is angle N, which is also the one that goes with angle I. Oops, I put the wrong number of hash marks on that. My bad. Now it goes with it. So the angle I goes with angle N over here. So that's a congruent statement. which is going to be useful when we get into proving triangles are congruent, because this is going to be shorter than writing out every single part of our triangles is congruent. Speaking of parts of triangles that are congruent, the next thing we're taking a look at here is a thing called the third angles theorem. The third angles theorem says if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangle are congruent. Now, you're probably looking at that going, well, yeah, of course, duh, which means this is going to be a pretty short proof. So if we want to write a little proof for this, first thing we're going to want is two triangles, because we got two angles of one triangle congruent to two angles of a second triangle, so we're going to need two triangles, and we're going to try to draw them, more or less congruent. So I'm going to draw a triangle like this, left here, and a triangle like this. Pretty close to here. So we're going to call this A, B, C. And we're going to call this triangle D, E, F. And we're starting off with two of these angles that are congruent. So I'm going to put two of these angles congruent. So I'm going to go with these ones and these ones. And it doesn't matter which ones we pick as long as we pick two of them. So that's what we're starting off with. That's our given. So we're going to put that in our table. So we got some statements, we got some reasons. We're going to put that under given. So those are the angles we're starting off with. So we're starting off with angle A is congruent to angle D. And we're starting off with angle B is congruent to angle E. So that's our given. And we're trying to get to the point where we can say that that means that our third angles also have to be congruent. So we're trying to get to angle C is congruent to angle F. So that's the thing we want to prove. Okay, now, if we know that our angles are congruent, we also know that their measures are equal. So we can also say this. So if angle A is congruent to angle D, then the measure of angle A is going to be equal to the measure of angle D. And our angle B is going to be equal to this definition of congruence there. Now, yesterday we said that if we have angles in a triangle, our triangle angle sum theorem means all of our angles are going to add up to 180. So that's a thing we can use here. So we can use that over here, and we can use that over here. So you can say angle A plus measure of angle B plus measure of angle C equals 180. Almost ran over. Okay, and we can also say that same thing about triangle DEF. So the measure of angle D plus the measure of angle E plus the measure of angle F is going to equal 180. And that's our triangle angle sum theorem that we were looking at yesterday. So triangle angle sum theorem. Now, once we've got that, if we have two things that are both equal to 180, then they equal each other. So we can set this stuff equal to this stuff and say that measure of angle A plus the measure of angle B plus the measure of angle C equals the measure of angle D plus the measure of angle E plus the measure of angle F. I know, this is about to get nice. So that's our transitive property right there. Now, the reason that's about to get nice is because we know that some of those angles are equal to each other. So we already have up here that angle A and angle D are equal to each other. So that means we can turn one of them into the other. So I'm going to go with angle A. So we've still got an angle A here, but we can also have an angle A over here instead of our angle D. And same thing with angle B and angle E. So I'm going to leave this one at angle B. And then this angle C and this angle F can stay. So that's just a little bit of substitution. So we substituted A in for D there and B in for E there. So substitution. Okay, almost done. Because now, if we want this, we have most of that. So we have angle C and we have angle F. We just have some extra stuff. But now that extra stuff matches. So we can cancel out our angle A's and our angle B's. So a little bit of subtraction gets us to the measure of angle C is going to equal the measure of angle F. So that's subtraction there. And then we can use our definition of congruence again, but in reverse. So you can say that angle C now is congruent to angle F. So we're going backwards with that definition of congruence there. Yay, we proved a theorem. Now, nicely, what we're going to do with this stuff mostly boils down to we're setting things equal to each other. So this is giving us more things that we can set equal to each other and then solve. I promise we're eventually going to do some more interesting stuff with this. But right now, it's mostly congruent things are equal to each other. So if we have something like this, where we know that triangle ABC equals triangle DEF, then we're finding our corresponding parts and setting them equal to each other. So if I'm looking over here at AB, if ABC is congruent to DEF, then AB is going to be congruent to DE. So this part over here, even though it's not marked, if we have this, we know this part has to go with this side over here. So we can take that 3y and set it equal to this 2y plus 6. And that's just a bunch of algebra. So now we're going to take this and subtract 2y, subtract 2y. These are gone. 3y minus 2y is 1y, also known as y. And boom, we got y. Yay! Now we're going to do the same thing with our x's. Because BC is going to go with side EF. So this x plus 7 is going to equal that 2x minus 1. And a little bit more of solving for x. So we're going to subtract the 1x. Because if there's not a number there, it's automatically a 1. These are gone. We got a 7. 2x minus 1x is x. And we're going to add a 1. Cool. These are gone. We got 8. Alright, we got x, we got y, we're done. Yay. One more. Yeah, we're not like done. Okay. Now, if we've got something like this, if we have triangle TRI is congruent to triangle AGN, and we have angle N here, angle N goes with angle I. And you may notice we don't have angle I, but we do have the other two angles. So if we know this is a right angles are 90 degrees. So we got a 90-degree angle over here, and we got a 61. 90 and 61 add up to 151. And all three of the angles have to add up to 180. So if we take 180 minus that 151, that'll give us our third angle. And that one's the one that we want to set equal to that one. So watch out for things like this where you might have to find the angle that you actually want to set equal to your other one. So don't get tricked into going, okay, well, I've got this, I've got that. Those are equal, right? Nope, these are the two that are equal. So we've got that 29 degrees there. Equals this 2x plus 3. And now we're solving. So we're going to take that 3. We're going to subtract it because we're getting rid of n. These are gone. 29 minus 3 gives you 26. We got 2x. We're dividing by 2. And boom, x is 13. Yay. All right. So that's pretty much it for congruent triangles. Numbers are in the description below the video. They are also on Google Classroom. Since we're not going to be back until after Thanksgiving break, once you're done with that, just go ahead and either take a screenshot of it, take a picture of it, and just email me that. And that'll be faster than waiting until we get back to actually physically hand it in. All right. I will see you next week.